In this session, let us discuss the behavior of various cost concepts in short run and long run. Let us first take up behavior in short run. Short run is a period in which only variable factors can be varied. It is a period in which the firm cannot change its plant, equipment, and the scale of organization. The output cannot be increased by expanding the capacity of the existing or a new plant. To meet the increased demand, it can raise output by hiring more laborers and raw materials or ask the existing labor workforce to work overtime. While the quantity of such factors as capital equipment, building remaining fixed. In the short run total cost are divided into total fixed cost and total variable cost. The factors such as raw materials, labor, etc., which can be readily varied with the change in the total output level, are known as variable factors. And the factors such as capital equipment, building, which cannot be readily varied and require comparatively a long time to make adjustment in them, are called fixed factors. With increasing output, total cost also increases. We can express it symbolically as TC is equal to TFC plus TVC. Even when no output is produced, the firm has to incur fixed costs. Total fixed costs are same irrespective of the level of output. Total variable cost varies according to the level of output. Now let us see the short run total cost curves. Total cost curve, that is TC curve, is a continuous curve which shows increasing output leads to increase in total cost. It cuts the vertical axis at a point above the origin and rises continuously from left to right. This is because even when no output is produced, the firm has to incur fixed costs. The total fixed cost, that is TFC curve, is parallel to output axis because total fixed costs are the same whatever be the level of output. The total variable cost, that is TVC, has an inverted S shape and starts from the origin O because when output is 0, the TVCs are also 0. They increase as the output increases. So long as the firm is using less variable factors in proportion to the fixed factors, the total variable cost rise at a diminishing rate. But after a point, with the use of more variable factors in proportion to the fixed factors, they rise steeply because of law of variable proportions. Since the TFC curve is a horizontal straight line, the total cost curve follows the TVC curve at an equal vertical distance. The next cost which we come across in the short run is the short run average cost. In the short run analysis of the firm, average costs are more important than total costs. The units of output that a firm produces do not cost the same amount to the firm, but they must be sold at the same price. Therefore, the firm must know the per unit cost or the average cost. The short run average costs are the average fixed costs, average variable costs, and average total cost. In short, AFC cost, AFC, AVC, and ATC. Average fixed cost, that is AFC, is equal to the total fixed cost divided by the number of units produced. The average fixed cost diminishes continuously as output increases. This is natural because when the constant total fixed costs are divided by a continuously increasing unit of output, the result is continuously diminishing average fixed cost. Thus, average fixed cost is a downward sloping curve which approaches the quantity axis without touching it. It is a rectangular hyperbola. The next one here is short run average variable cost, or in short SAVC. SAVC or just AVC is equal to total variable costs at each level of output divided by the number of units produced. That is TVC divided by Q. The average variable cost first declines with the rise in output as larger quantities of variable factors are applied to fixed plant and equipment. But eventually they begin to rise due to the law of diminishing returns. Thus, the SAVC curve is U-shaped. The next short run average cost is short run average total cost, or SATC, or just SAC. Short run average total cost are the average cost of producing any given output. They are arrived at by dividing the total cost at each level of output by the number of units produced. Hence, SATC is equal to TC divided by Q, or it can also be calculated as AFC plus AVC, that is average fixed cost plus average variable cost. Average total cost reflect the influence of both the average fixed cost and average variable costs. At first, average total costs are high at low levels of output because both AFC and AVC are large. But as output increases, the average total cost fall sharply because of the steady decline of both AFC and AVC till they reach the minimum point. The next short run cost is the short run marginal cost. Marginal cost is the addition to total cost by producing an additional unit or one more unit of the output. Hence, SMC, that is short run marginal cost, is equal to change in total cost divided by change in quantity, that is delta TC divided by delta Q. It is the total cost of n plus 1 units minus the total cost of n units of output. Since total fixed cost do not change with output, marginal fixed cost is 0. Marginal cost can be calculated either from total variable cost or total cost. The result will be same in both the cases. As TVC or TC first fall and then rise, marginal cost also behaves in the same way. The SMC curve is also U-shaped. So this is what we discussed, the behavior of the various costs in the short run. Now let us analyze the behavior in long run. Before that, we can conclude that the short run cost curves are the short run average variable cost curve, the average fixed cost curve, this short run average cost curve, and the short run marginal cost curve. But it is important to remember here that short run average fixed cost curve is insignificant. Now let us move to the behavior in long run. Long run is a period of time during which the firm can vary all its inputs. In long run, output can be increased by expanding the capacity of the existing or a new plant. In long run, none of the factors of production will be fixed and all can be varied to expand the output. Long run cost of the production is the least possible cost of producing any given level of output when all inputs are variable, including the size of the plant. Hence, there will be no fixed costs. All costs are variable. In the long run, the cost curve is the long run total cost divided by the level of output. Because in the long run, we have only long run average cost and long run marginal cost. There will be no long run fixed cost as all the factors become variable and hence fixed cost will be 0. Hence, we will be concentrating on long run average cost. Long run average cost is the long run total cost divided by the level of output. A long run cost curve depicts the functional relationship between output and the long run cost of production. LAC, that is long run average cost curve, shows the minimum average cost of producing various levels of output from all possible short run average cost curves. So LAC can be derived from the short run average cost curves. As we can look at in the diagram that the LAC has been drawn from various small short run average cost curves. While the SAC curves correspond to a particular plant, since the plant is fixed in the short run, the LAC curve depicts the scope for expansion of plant by minimizing cost. Note that in the figure, each SAC curve corresponds to a particular plant size. This size is fixed, but what can vary is the variable input in the short run. In the long run, the firm will select that plant size which can minimize costs for a given level of output. Thus, the choice in the long run is to produce at the plant size that can minimize costs. Graphically, this gives us a LAC curve that joins the minimum points of all possible short-run average cost curves as shown in the figure. Thus, the long-run average cost curve is also called an envelope curve or planning curve. LAC curve will be flatter than the SAC curve. The curve first falls, reaches a minimum and then rises, giving it a U shape. We can use returns to scale to explain the shape of the LAC curve. Returns to scale depict the change in output with respect to a change in input. During increasing returns to scale, the output doubles by using less than double inputs. As a result, LTC increases less than the rise in output and LAC will fall. In constant returns to scale, the output doubles by doubling the inputs and the LTC, that is long run total cost, increases proportionately with the rise in output. Thus, LAC remains constant. In decreasing returns to scale, the output doubles by using more than double the inputs, so the LTC increases more than proportionately to the rise in output. Thus, LAC also rises. This gives LAC its U shape. Coming to the next important cost in the long run, that is long run marginal cost. Long run marginal cost is defined as the additional cost of producing an extra unit of the output in the long run, that is when all inputs are variable. The LMC curve is derived by the points of tangency between LAC and SAC. Note, an important relationship between LMC and SAC here. When LMC, that is long run marginal cost, lies below long run average cost, long run average cost is falling. While when long run marginal cost is above the long run average cost, long run average cost is rising. At the point where long run marginal cost is equal to long run average cost, long run average cost is constant and minimum. Hence, in this session, we discussed the behavior of cost in the short run and long run. For further studies, these books can be referred. In the next session, we shall take up cost volume profit analysis. Thank you.